action. Hi everyone, Alicia McGill here, and today I'm going to talk about tiles, algebra tiles specifically, and this is going to help us work with our students for the appendix in Integrated Math 1 for CPM. All right, let's start here with understanding what these are. This is an x, this is a negative x, this is a positive x squared, negative x squared, and then we have our little guys. Here are ones and our negative ones, okay? The students should have a little bit of experience, not with tiles necessarily, but zero pairs from 7th grade working with integers. So they should understand that, for example, a positive 1 and a negative 1 make a zero pair, and in a sense, cancel out or make zero. So having that in the back of their minds is a good thing, and you might want to remind them of that before we work with algebra tiles. Let's take a look at a problem. CPM doesn't start with numbers, but I like to start with numbers. So I'm just going to, instead of going to the abstract, I'm just going to give you a problem to represent like this, 5 take away 2. Oh, you guys are so smart. I know you know the answer, right? Okay, super easy. Let's represent that here with 1, 2, 3, 4, 5. Now, this subtraction sign at the bottom, take away, positive 2, so we're going to take away 2. How we're going to do that is understand that this is in the negative, this is in the positive. If we flip it to the positive, then we have to flip that over. And then you can easily see that we have a zero pair right here and a zero pair right there. Or altogether, we have that as a zero pair. And hi-ya! We're going to get that out of there. And we're left with 3. Now let's move to an algebraic expression. So let's look at the problem. 2x, so there's 2 x's, plus 3. There's my plus 3. And then we're going to subtract x. Here's my x. Plus 1. Okay, so what that looks like for this next example is 2x plus 3, and we're going to subtract this entire quantity, x plus 1. A lot of students make mistakes with the distributive property because they want a minus x and then they add the 1, and they don't really carry out because they don't visually see it. This is going to help solve that problem. Okay, this is pretty cool. So we're going to do what we did last time, and to get from here to here, from the minus to the positive, we're going to flip it, because that's the same thing, okay? That doesn't change anything, all right? Now we're going to get rid of our zero pairs, which I have a negative x and a positive x, bye-bye, and a negative 1 and a positive 1, bye-bye, and I'm left with x plus 2. So when I write that answer, you might be thinking, okay, so what? Kids could have just, subtracted the whole parentheses, combined like terms. Well, yeah, but after doing a few of these, they're going to have that moment where they realize that that's exactly what they're doing. So if we bring it back to the math here, we could see that what we essentially did was subtracted an x from our problem, but we also subtracted a 1. And so that's how we got this 2x minus x, which is x, and this 3 minus 1, which is 2. And so it works. And the beautiful thing about this is they practice this enough times and they really have a better understanding. All right, so that concludes the first part of simplifying expressions and really looking at how we can add and subtract using zero pairs. The next one is equations. Stay tuned.